Hello, this is Walter Leite, and in this video, I will show you how to estimate propensity scores using classification trees and random forests. This example is presented in chapter 2 of the book, Practical Propensity Score Methods Using R. I'm using the R software to demonstrate. So this is the third part of this example. In the first part, I showed how to handle missing data. The second part, I showed how to use logistic regressions to estimate propensity scores. And now I'll show you how to use classification trees and random forests. So the data set has already been loaded, and the missing data has already been inputted. I have two data sets, one that has a single data set where the data was imputed just once, and another one with 5 imputed data sets. For classification trees, I'll use the package party in R. So the first thing I do on line 194 of this code is load the party package. Now I'm using C3, the function C3 to run the classification tree. Now, classification trees are not ideal to estimate propensity scores because they don't generalize well, but I'm demonstrating it as a building step to random forests. So this is the formula with all the variables. The good thing about classification trees and random forests is that they will automatically search for nonlinear terms and interactions in your data. So you just, this formula is not the actual model, it's just a way to declare what the predictors are. Once this finishes, it will provide a tree, and I can plot here my tree, which I can show you looks like this. And it's showing the splits. The first split was by race. It split categories 2, 4, 7 from categories 1, 3, 5, 6, and the splits aim to reduce heterogeneity in the groups. And here we have the terminal nodes that are the most homogeneous, and you can see that several splits were done. And the final predicted probabilities are based on proportions in the final nodes, proportion treated. I can get this as PDF as well. Now, as I said before, classification trees, they tend to be affected by different measurement scales of variables. And the solution for that is to use random forests instead. Random forests are collections of trees, but instead of using all the variables and all the cases, cases are bootstrapped with replacement and variables are sampled. So I'm using the same package party, and I have this set of variables, but I specify here that in this mtry argument that I'm only sampling 5 variables per iteration. In other words, each tree is going to be grown with just 5 variables. A good guideline for the number of variables is for each tree is the square root of the total number of variables that you have in your propensity score model. And I'll grow 1,000 trees. And so the C forest runs the tree, and here, because I have sampling weights, I declared what the sampling weights are. Now it's not possible to visualize the random forest like we visualize the regression trees because there are 1,000 of those. To get propensity scores from the random forest, I use the function predict, and say that the type is prob, which means probability, since propensity scores are predicted probabilities of treatment membership. Now, the predicted probability is a matrix with both probabilities for both treatment and control. We want just the probability of treatment. Therefore, this code here is necessary to just pick that probability of treatment that we want. This is it. This is how to fit regression trees and random forests. Classification trees and random forests to estimate propensity scores.